Hey, this is Michael Garino, and I'm going to give you an overview of how to set up production-grade Kubernetes infrastructure in under 30 minutes using Plural. Um, the way we're going to do this is we're going to use Plural Cloud, and from there use a lot of the built-in service catalog that comes pre-installed when you connect your cloud infrastructure to Plural. The basic way to get this started is you'll first log into app.plural.sh. You can see I'm already logged in our UI, and then click the Create Cluster button. This is just going to go through a basic install wizard for the number of different ways that you can set up Plural. And you can see there is an option to self-host. This has always been an attribute of Plural, and it will remain so. You can, in fact, self-host on your infrastructure if that's something that's required for your business's security and compliance regime. Or you can use Plural Cloud, which is just the quickest way to get things going, and also adds some additional benefits in terms of us being able to host on your behalf a full-blown observability stack, including log aggregation and time series metrics with Prometheus. Now I'm going to go ahead and select through into the wizard, and you can see there is a shared and dedicated option. If you have an enterprise plan, we can actually provision an instance on an entirely dedicated Kubernetes cluster with a dedicated Postgres database underneath it for you. That just gives you basically unlimited scalability and complete data segregation as well. If you don't need that degree of scale or security, you can just use the shared tenancy model, which will pack your instance alongside others in a scaled out Kubernetes cluster. And what I'm going to just do is go through and quickly fill out this form. I'm going to just name it YouTube demo and start provisioning it. This will take about 1 to 2 minutes in a lot of cases just to set up the actual instance and register its DNS records and SSL certificates. So we'll give it a little bit of a break and come back once that's all done. All right, our console instance has been fully provisioned, and all we really need to do then is log into it and start the actual setup process from there, which is running this Plural Cloud command. So we can go ahead and click the login button. It's going to direct us to the URL of our console. And it comes pre-installed with login with Plural, so you don't have to think about login security or anything like that. And from there, it's just going to give you the actual instance setup wizard. There's a couple of basic things here. The first is we want you to set up a GitHub application just to make sure that the SCM integration that we have is working from the get-go. I've already installed this on our org, so what I'm doing is I'm just going to find the installation ID real quick, which is that guy right there, which is the manual process of doing it. You can go through the OAuth flow as well. If all else fails, for what it's worth, you can actually select the provider itself manually and use GitLab or Bitbucket. From here, we can actually set up our first webhook just to listen to updates to PRs and everything like that. That drives a number of the workflows within Plural. And then finally, it's going to ask us to generate an access token, which I just did right here, and run the Plural up cloud command. This is going to ask me to select the cloud console I want, and then use the credentials I just gave. And what this is going to do is it's going to just give me a basic intake form for how I want to define my cluster. And from there, it's detected that I haven't actually set up a Git repository, and so what it's going to do is it's going to actually set up a new one for me. And I'm going to use GitHub, and it will OAuth to GitHub from there. And we're just going to create the Git repository to then complete the rest of the process. this is actually asking us to set up a domain to deploy all our applications in. The expectation, like it says, is that you have already registered this for the target cloud's DNS provider. So in the case of AWS, it would be Route 53, but it could be GCP Cloud DNS or Azure Cloud DNS. It's okay if you don't have this already set up. You can leave it empty and figure it out post hoc. That's totally fine. Or you could put, a value in and figure it out from there. Cool. So what this has actually done is it's generated a basically baseline starter repo for you to run the entire Plural workflow. If I were to go to the repo itself, you can see it's already mostly generated. The basic structure actually is described in the README that we generate for you too. So feel free to peruse that just to get an idea of how everything works. It shouldn't be that hard of a read. But the TLDR is the root of the entire GitOps process is at this Bootstrap folder. That's where most of our CRDs will reside. That just configures the entirety of your installation. There is also a Terraform subfolder here where most of the Terraform code that we generate will live. That includes the management cluster itself, which is the Terraform stack that's running right now. So you can see actually, how that's defined. There's an EKS cluster and VPC and everything like that that's being provisioned. There's also a core infra stack, which we'll see in a bit. But that basically sets up an initial network topology for you. It's just a dev and prod VPC in the case of AWS. Registers the details of the service context and also sets up the DNS configuration that we had basically specified in the intake form. This is basically completely opt-in. You can decide to completely reconfigure this if you want to. In fact, the entire approach that Plural does, which is this code generation approach, is meant for basically long-term reconfigurability. What we're trying to do is give you a completely working and validated set of configuration to get started with, but you have a completely functional end-to-end GitOps process to modify that to your specific business requirements afterwards. That basically solves a lot of the graduation problems a lot of past platforms will have, where you very frequently will outgrow the basically limited configurability and black box nature of those platforms. It also really nicely dovetails with a lot of the AI coding assistants that you likely are already using within and turbocharging your workflows. They're going to love the fact that they have very well-known tools like Terraform and Kubernetes, manifest and everything like that to chew on and then suggest fixes or accelerate your process. This is going to take, for what it's worth, about 10 or so minutes to fully provision the management cluster. So we're going to do another quick break to let it finish itself out and then come back when it's done. Okay, as you can see, the plural up command that we just ran has fully completed. And you can see the actual management cluster has started to ping in the UI, and we're basically ready to go. Just to give you a quick orientation of some of the stuff you get out of the box with Plural Up as well, now that we have it all established. You can see these Logstash and VM agent services that are available in this cluster. They will be deployed on every cluster because it is configured as a global service. You can see them right here, Logstash and VM agent. That is going to basically be the agents that will do our built-in observability. You don't have to configure those at all by hand. They'll just be there with Plural Cloud available by default. You can also see how they're configured in your new repo. They will be in the observability folder. And if you wanted to opt out, for instance, from the logging, you could just remove those and push it to main, and it will the GitOps engine will see the change and remove those agents from your clusters. The other side of this as well, and we'll see that in a second, is we do set up your network stack for all your Kubernetes clusters by default. This is usually a little bit of a fiddly process, depends on the cloud exactly what you need. But the basics are normally cert manager, something like external DNS for registering DNS names, and an ingress controller, which we use at Ingress Nginx, which is kind of the default within the Kubernetes ecosystem. For AWS, you'll also need the AWS load balancer controller because otherwise Kubernetes will only be able to provision classic ELBs. Usually you like have to have an NLB in front of Ingress Nginx just for performance and cost. That'll all be basically ready to go, and will provision on any net new cluster that you create with Plural. Now, what we want to do is we want to first create our Kubernetes fleet, which would be a dev and a prod cluster, and then we want to start deploying into them. The quickest way to do that is to go into our service catalog, which gives you a whole lot of pre-built and validated provisioning templates for a variety of different use cases. The infra catalog that we have is the set of templates for the creation of Kubernetes infrastructure. So you can see there's a number of different workflows that we modeled in here, but the cluster fleet setup will actually create our fleet, and we're just going to name that demo right now. We're going to put it in the same region as our management cluster. We're going to deploy it to USEs 2. And the way this works is it will generate a PR for each of the various different things that we're going to be provisioning. So this PR right here is going to set up the manifest necessary for creation of the fleet. And it's a relatively basic little process. It's going to set up these infrastructure stack CRDs, which are, in this case, looking for Terraform that was already generated by Plural Up. This is just some default Terraform that we've created for you for creation of Kubernetes clusters. And it also actually will create a pipeline of those services to control upgrades. So you end up having a really nice and clean process that you'll get whenever you need to upgrade those clusters, which is really the most meaningful day two workflow that you need for the management of Kubernetes. If you want to learn more about how Plural can help with the upgrade process as well, we have other videos going into our upgrade assistant and the variety of different things we can do to make Kubernetes upgrades as hands-off and on autopilot as necessary. Cool, so we merged in that PR. I'm just going to sync this service to have the system detect the change as quickly as possible. And you can see there's now these two services being provisioned to actually create those clusters. So this is the Plural stack that will create the dev cluster and the Plural stack that creates the prod cluster. If we look in, we can actually see that they're running a standard Terraform workflow for that Terraform code each of them are listening to. So we will wait a little bit for that to go on. And I can show while the Terraform commands are chewing what it's actually listening to. So Plural Up is generated in that Terraform folder that provides a lot of the Terraform code for your infrastructure. This modules clusters AWS will be the EKS setup, and it really uses a lot of pretty straightforward modules to set everything up. It uses AWS's EKS module, then some modules for setting up our EKS Insight integration and some base add-ons as well. And then finally, it will install our agent on the cluster at the very end with our own Terraform provider. That's what the Plural cluster resource right here does. And you can see we, as part of our initial setup, we're wiring in IAM roles, VPC IDs, and a variety of different metadata into the cluster resource so that all those things that we have by default will work. And like I had mentioned before, this is meant to be post hoc reconfigurable. So if you wanted to, modify the details of any of these, you can actually go in and check out the Helm values that we're generating and do whatever you need to do to fit your own business use cases. Okay, cool. And you can see the Terraform plans have already generated for these. We can go ahead and approve them. And there's a plan for this one as well. Again, we can look it through and approve it. And like we has seen before, this is going to take like another 7 to 10 minutes. That's just how long AWS takes to create a Kubernetes cluster. So we're going to let that churn in the background and come back when it's ready to be continued. All right, our clusters are fully provisioned and we can get going with the rest of the actual process. So if you wanted to just give a quick peek, you can see the two clusters are also registered in the console. That was due to the Plural operator getting installed on them. And now we're going to start setting up the applications we want to set up. So within the context of this example, let's just say that we have a need to set up some data engineering infrastructure. A good example of what you might need is something like dagster. So let's create a dagster instance on that dev cluster. And we had used qa.plural.sh as our app domain, so it'll be on dev.that app domain. And then let's just say the dagster bucket, and this will need to be something that's going to be unique. This seems pretty unique to me. I doubt that there's an existing one with that name. And this will again generate a PR for us to provision that dagster instance. So if you wanted to give it a quick, well, like a clear view of what exactly was going on, you could look at this PR in detail. But it's fundamentally just setting up the scaffolding to provision the Terraform. That would be registered right there. And then the Helm chart for dagster. And then it's going to also provision the OAuth proxy integration for dagster as well. So Plural does come with a built-in OIDC provider that is integrated directly with Terraform, and it makes it easy to set up a lot of these complicated applications as a result. This is a Terraform code itself. You can see the Plural OIDC provider resource that's actually registering the OIDC client for this application, and it's going to be using an RDS database for persistence, which just sort of gives you a production grade install of this application by default. The idea being it should be pretty low maintenance, if not absolutely no maintenance after the installation from here. Cool. So we've got that merged. And then the next thing is we want to set up a microservice, and it's going to need to be, a dev and prod instance, everything like that. Let's just call it demo. And again, we're deploying on AWS. We're going to use the dev cluster for our dev cluster and the prod cluster for our prod cluster. We have an existing image for this already that we've baked called Plural CV test. And it will be at that tag. You can change the port, but it defaults at port 80. And we're just going to give it a domain for dev and a domain for prod. And from there, we will set this up as well. And you can see, the details of exactly what we're going on if you wanted to look at this closer too. So again, this is sort of setting up the scaffolding of the Helm chart installs for the dev and the prod service. But there's also going to be a pipeline to control upgrades. So it's going to be basically CD by default. In this case, it uses our observer resource to pull that OCI image registry for new Simbers and kicking the pipeline from there. So all you would need to do within your CI is just to basically maintain a Simber release process and bake and push that into the registry that you had configured, and the system will auto deploy from there. And it does register it as a Plural Flow, which I will show in a bit. And for the database that's needed underneath, the idea is this is going to be a Postgres backed stateless service. It's going to provision the RDS database as well, and expose the actual database to the application using our ability to input outputs from Stack. So if you looked at each of these services, they have an import of the Stack for dev and the Stack for prod. That allows us to actually wire in the database URL that's generated, as a secret for that service. And of course, you can, reconfigure exactly how this all works based on the nature of your application and how you decided to containerize it. Cool. And you can see there are, again, a number of stacks. All of these required databases, so they're going to have a Terraform workflow around the maintenance of that database. And if we were to go in, we can see, the actual stack that was generated to configure those. So this is the one for Dagster. We can go ahead and approve it. This is the stack for the prod service. It looks like it's also ready to be approved. And again, it's just basically provisioning a database, making sure it's accessible from the cluster that will be located on, and going from there. Similarly, again, provisioning a database, making sure it's accessible, and going from there. Cool. Now from here, we're basically going to have another cloud impose waiting game. It takes about 10 minutes for AWS to create a Postgres database, so we just have to wait for all of these to fully provision. Not much else we can do about it. So again, we will basically let that sit and bake and come back when it's ready to go. All right, our databases have finally finished provisioning. You can see it took a little bit longer than I was expecting, at about 15 minutes or so. But now that all of that is done, and you can see the databases for the Devon and prod instance of our little Postgres-based microservice are also provisioned, we should actually be able to see what's going on. So you can see the Dagster instances have been marked as healthy. We can also go to our flow and see the two Devon prod instances available here. And then also the pipeline to do the upgrade for those is also available for us. You can see the within the pipeline, it actually has found a new version for that. So that's what that guy is right here. And if we wanted to, we could actually start deploying that new version as well. So, I'll just go ahead and let that happen. Cool. And the in the Dagster instance. So if we were to go to the Dagster instance, we had put it on dagster.dev.qa.pluralsh, which you can see it's been built with integrated Plural login. So it's bouncing us back to our Plural account, and we can actually see the running Dagster instance if we wanted to. We can, see it's got a basic example user code instance already loaded up in it that we could actually launch some runs as well. And then finally, I was just going to show the basics of the observability integration. So all those clusters, like we had mentioned before, will have Logstash and Victoria Metrics Agent on it. That means that you will have actual telemetry and observability available by default. So if we were to go to the Dagster instance, we can go to this log tab, and you can see a full log tail of all the various different pods within this instance, and there's a fair number of them. And if we wanted to, we could actually, get more advanced search and filter of those logs as needed as well. So that's available for any Plural service, and it also inherits the authentication system within Plural as well. Now, you can also, for anything that would be a compute-bearing resource within Plural, so that would be something like a deployment, like you see right here, you'll also get basic saturation metrics available for that resource, or you can also get a heat map of the layout of the utilization as well across the various different pods or nodes that you might have. That also works, for what it's worth, on our overview tab. So if we wanted to go and look at the utilization on the cluster level, you can see the various different nodes for that cluster, and the namespace utilization and everything like that. So you get a pretty comprehensive set of basically observability and troubleshooting tools right there out of the box. And if there were any issues, and you can see there has been some configuration issues detected with this specific cluster, We will actually automatically detect it from our agent and service them directly in the cluster UI. And you get a holistic health score as well to gauge how basically the health of your Kubernetes configuration. You can see all of these are basically effectively 100% healthy. If you had more critical resources that are basically failing provisioning, something like an ingress or a certificate that could prevent traffic from being able to reach your cluster, you will get substantial deductions on your health score. Or if we were to find something very critical, like say a kube proxy not being able to provision on the cluster, it would be immediately marked into a failings grade, and you would be it'd be very evident to you that you have some substantial issue with the cluster that needs attention. But yeah, that's a pretty quick overview of exactly how to use Plural Cloud to set up some pretty extensive Kubernetes infrastructure throughout the scope of this demo. We've created a dev and prod Kubernetes cluster. We've created a full stack application in dagster for data engineering purposes. And we've also created a dev and prod microservice with a full deployment experience around that microservice as well. So if you want to learn more about the capabilities of Plural, feel free to look at some of the other videos that we have on our channel. We can dive into anything from advanced Kubernetes upgrade processes to a full DevOps AI experience that you can get out of the box with Plural as well. Or if you're interested in a demo or further conversation, feel free to reach out to us over email or our Discord. Thanks for watching the video, and have a good rest of your day.